Okay, so we have over 114 elements with 90 of them occurring naturally, and the rest are synthesized or they are made artificially. So if we have over 114 or close to 114 elements, there's a need for this element to be represented by symbols. Hence, like I said, the three methods that we use to represent the element are spelled out. Let's take, for example, who can give us elements that start with C? Let's mention elements that start with the first letter C.
Carbon, chlorine.
Okay, carbon, chlorine, yes, let's go on.
Cobalt,
okay.
Cobalt.
Cobalt, what else?
Calcium.
Calcium, yes, very good. And we have more. Carbon,
cadmium, cadmium, cadmium.
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 Yes.
Copper.
Copper, yes.
Yeah.
Very good. Okay, and so on and so forth. So you realize that they all have their symbol or their first letter as C. So if we go by representing them using the first letter, we end up having a repetitive C. Hence, it will look as if we are contradicting ourselves. Also, let the student know whenever they are writing symbols of elements, the first letter is always a capital letter. This is always an emphasis when marking WAEC. Maybe they ask the student to write the symbol of an element, or they ask them to represent an equation, and they want to write, for example, carbon. Now, using carbon, carbon has a symbol C. If you write your carbon like this, that's correct. But if you write it like this, maybe you want to write carbon dioxide, and you're now writing CO like this. In chemistry, you have not written the formula. What they have written now is a different thing entirely. So let the student always know that the first letter of the chemical symbol is always a capital letter C. So that is for carbon. Then if you look at chlorine, chlorine has its symbol as Cl. This capital letter C with a small letter L, not capital letter L again. And this L now is coming from another letter in the name, which is the third one. So that's why I said most times it's always the first letter and any other letter, but sometimes they go with the second or the third. Then for cobalt, cobalt has a symbol CO. Then calcium is Ca. Cadmium, like Mr. Gabriel told us, so cadmium should be what? If I'm right. Let me see if it's
CD. CD.
Thank you very much. CD. Then copper.
Cu.
Cu. Very good. So the student might ask you in class, if you list them now, apart from copper, copper is having the symbol Cu. But if you actually check, we have C in the first letter, which is right, but the U is not there in the spelling. So where is that U now coming from? Is from the Latin name. So copper, the symbol of copper that you are seeing as Cu is from the Latin name, which is called cuprum. Hence, you see it as Cu. Is that taking place? Then again, can we try if there's any element that the symbol, you are finding it, the symbol does not correlate with the spelling? Is there any element like that that you can think of?
Gold.
Gold, okay. The symbol for gold is what? Gold is AU. Then maybe we also have silver. Silver is what?
AG.
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 Thank you. Then
lead.
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 Yes, lead. PB.
Iron.
Good. Iron. ION. FE. There's a difference between
Sodium.
sorry?
Sodium.
Sodium. Thank you. And A.
Potassium.
Yes, potassium.
Potassium.
Great service. Thank you. Okay, and so on. Now let's now look at it this way now. Gold has the symbol AU from the Latin name, which is Aurum. Then silver from the Latin name argentum. Gold from the Latin name plumbum. Iron, ferrous, or ferron. Ferron.
Ferrum.
Yes. Then sodium, natrium. Potassium, kalium. So all these symbols are from their Latin name. So that's why you see them like that. I think that is for symbols of elements. Nobody will ask the students to list the criteria for writing symbols of elements, but maybe they might just ask them what is the symbol of the elements. That way now, you will need to know the symbol, but not the criteria for writing symbols of elements. But however, it is important to let the student know the criteria for writing symbols of elements. Any question before I move on to the next thing? Okay, in the absence of any question, I believe we are good to go. The next thing we'll look at now is formula. Formula of compounds. Formula. Who can try with a definition of formula? What do you think formula will be? It depends on definition. Okay. While we try to wrap our head about this, let's refresh our memory a little bit. Can you tell me one difference between mixture and compound? Mixture and a compound.
A mixture contains two or more substances that are physically combined together and can be separated by physical means. While compound contains two or more substances that are chemically combined together, they cannot be separated by physical means.
Very good. What, any other differences? That's very correct. More differences? More differences? There's a particular one I'm expecting with that one button. That difference you don't give me very correct. In terms of definition, you are able to differentiate it. If you remember very well, you will also realize that mixtures are not represented by chemical formula, but compounds are represented by chemical formula. That is why I'm trying to drive at this formula. Okay, so a formula is a representation of the composition of a compound. A formula is a representation of the composition of a compound. Is that okay? Are we together?
Yes, we are.
Okay. So if a formula is a representation of a compound by symbols of the component elements that makes up that compound, the representation of a compound or by its component elements that makes up that compound, like the formula. There are basically three types of formulas. Types of formulas. There are three. You can let me start with one. Empirical formula. Then you can help us with another one. The supermark, can you help us with one? Types of formulas. There are three. I've listed one already. Empirical formula.
Molecular formula.
Okay, thank you. Molecular formula. And the last one. The last one. Okay, maybe I'll give you a clue. The word of that last one I'm looking for start with an S. That's right. It starts with an X. Structural formula. So those are the three types of formulas that we have. Empirical formula, molecular formula, and structural formula. But we are not looking at how to find empirical formula, molecular formula, or the structural formula. I think another day we'll look at that. But I believe you should be able to do this, or the students should be able to. There's no issue with this aspect in finding any of them. And so just let the student know that these are the 3 types of formulas that we have: empirical, molecular, and structural formula. Then let them know the definition of them, because I think I saw it was in this year's lecture where they were asked to define empirical formula. That lecture or why one of them asked them to define it. So let them know the definitions of those formulas. Moving on now. Then IUPAC, nomenclature of compounds. Remember, we have 2 types of compounds. Who can try? We have 2 types of compounds. It's an interactive class also. I won't be the only one talking now. So types of compounds. No response?
In terms of what?
Basically, we have basically 2 types of compounds. We have organic compounds and inorganic compounds. Organic compounds and inorganic compounds. So in terms of this aspect, you are looking at IUPAC nomenclature of inorganic compounds. I just go correct. I wanted also to get that first. So it's supposed to be IUPAC nomenclature of inorganic compounds. That is what we are looking at. And when you get to organic compound, that is organic chemistry, where you need to look at IUPAC nomenclature of organic compounds as well. But for this stage, which is SS1, which is the elementary stage, it is IUPAC nomenclature of inorganic compound. That is what the students might be asked questions on. But when they get to SS2, you can now look at organic compounds, that is in organic chemistry. So the word IUPAC is just like an acronym. I've already said that times that number. It simply means International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Why? The word nomenclature means systematic way of naming. So International Union of Pure and Applied Chemistry, systematic way of naming inorganic compounds. And that is IUPAC nomenclature. How do we name compounds? What is the systematic method? Compounds are named. And in naming inorganic compounds, there are rules that must be followed. So we will not be looking at the rules one by one, but as we move on to examples on naming compounds, then we will now begin to look at how to apply the rules. Like I think Mr. Gabriel dropped on the platform when someone asked what is the formula of a particular compound. He wrote something that I love. He said using the crisscross rule. So in the that is also one of the rules of naming compound. We apply that one called crisscross rule. But to explain what that rule is all about in no distant time now. So first of all, when you are asked to write the IUPAC nomenclature of a compound, that means you would be given the formula of the compound and asked to write the name. Or sometimes the student can be given the formula and asked to name it. So whichever way it comes, that is the question that you could be faced with such, or the student could be faced, let's put it that way. But in the first thing is, let's say, for example, now, write the IUPAC name of the compound below. Let's take this two first of all. One, IUPAC name. We are looking at IUPAC name now. And for 3. Let's start with that. And then let's also look at another. I'm just giving this simple ones. Let's start from this ones. Let's build it up from here. Are with me? Can I move on now? Hello? If you can hear me, let's.
Yes, you can move on.
Yes, we can hear you.
Okay, so this, maybe we'll do this now. And then the last one now. Okay, so now we are asked, give the IUPAC name of each of the following. When we are looking at name, then after this, we'll look at the formula. So this is formula, which is the formula of the compound. And the first thing you should let the student know is they should be able to identify how many elements that makes up the compound. Yeah. So, like the first one, how many elements is in this compound?
3 elements.
Okay, thank you. We have 3 elements. 1, 2, 3. However, this numbering is wrong, but I just want to spell it out for you to know the 3 elements, which is Na, N, and O. The Na is the symbol of which element? Sodium. Hence, we started with sodium. So now, when you have 3 elements that makes up the compound, the numbering is 1, 2, and 3. That is, to your extreme left, to your extreme right, and the middle one becomes the 3. So that is how to number it when you want to name it. So this numbering is just to tell you which one comes first in terms of the name. So for Na, NO3, Na we said is what? Symbol of
Sodium.
Sodium. So thank you. So that will now be sodium. Then I came to 2, which is O. O stands for oxygen. But when it's in a compound, we say oxo. OXO. Then also we look at the number here, that is the subscript. Yeah. Oxygen has 3 atoms here. So we use the word tri. Tri for 3. Tri when it is 3. Di when it is 2. Tetra when it is 4. Penta when it is 5. Hexa like that. And so on and so forth. Any question? So this is sodium trioxo. You know why it is already tri now. Then N, which is what?
Nitrogen.
Nitrogen. Now, because it's in this compound, we'll say nitrate, no longer nitrogen. Then one more thing. The third one, you will now calculate the oxidation number of that third one. Then for sodium, if you check your sodium, sodium is number 11 in your first 20 elements. It belongs to group 1 in the periodic table based on its electronic configuration, which is 281. Then if you write that, the last number, which is a 1, becomes the valency of sodium. So in this compound, the valency of sodium is 1. So this is 1. I don't need to put the plus anymore. Plus the valency of sodium, nitrogen, which I'm looking for, plus oxygen always has its oxidation number as -2 when it is in a compound, except the compound is a peroxide, like maybe hydrogen peroxide and the rest. But in this case, it is not a peroxide. And oxygen again has its valency or its oxidation number as -2 because it is a group 6 element. It needs 2 more electrons to attain stability. Oh, I'm looking back. So this will now be -2 times 3, and that gives me.
Sorry, you were breaking, no?
Okay, where exactly? Where exactly?
You were talking about sodium or
I wrote these numbers out, right?
Yes.
Then we said Na being the first one comes first. That is why you see sodium here. Then the second here is O, which is oxygen, but we use the word oxo. And oxygen here has 3 atoms. You are saying tri. If it is 2, we use di. If it's 4, we use tetra, like that. So that's why you're saying tri also. So this tri also tells me 3 atoms of oxygen. Then we come to the middle one, which is nitrogen, because that's the symbol for N. But I will not say nitrogen, I'll use the word nitrate.